So my name's Adam Ivey, and this is the talk about Kegerator, the IoT DIY or DIY IoT Kegerator. I'm going to warn you first off, I am neither a brewer nor an electrician. I write code, that's pretty much it. So I had a whole team of people that I will show you here who helped make this thing. So first, what are we talking about? It's a smart IoT beverage dispenser. So beverage agnostic, although we use beer. Completely custom software. Found a few things on the market afterwards that you can get just like a whole software kit and things that you can put together to make something kind of like what we made, but we had a lot of other special customizations into it. So we just did it all from scratch. A mix of both using the Beagle Bone Black or BBB, just similar to a Raspberry Pi, and then a bunch of other custom hardware that we put together. With a modified fridge, a dandy mini fridge. I'll get a little more into that. Like I said, it's all DIY. So we thought I had this idea like 2014 at the end there, mulled over for a little while, and then finally last year in June we got together and we're like, let's actually build this thing. And it turned out that it was about a weekend, plus a few days, about a week worth of work to make this a reality. Took about 30 hours together. We spent some time in my garage for a whole day, as well as just getting together through some lunch times to do planning and purchasing and things like that. And by the end, I think we spent a little under $500 on all the parts. Some of the things we actually it didn't work out, and we did buy 3 Beagle Bone Blacks. I think we only really needed 1, so there was a little bit of experimentation in the materials as well. So this is the team. We actually have Michael in the audience and CJ, so maybe they can help field some questions at the end. And I did mostly node.js code. Had another web dev, did more of the LCD and RFID reading code. This guy did a bunch of electronic work, because like I said, I'm not an electrician, but he did all the voltage, stepping up and stepping down, and setting up a custom cape for the LCD, and a bunch of other things like that. So here we go. All started with an idea, right? So we started whiteboarding. What do we actually want this thing to look like? What kind of thing? How could this work? Right? We need some kind of refrigeration device. We need, a tube with a spigot. And so we just started drawing up ideas. So phase 1, success. And then we got in a garage, a bunch of materials, and just started hacking together. This was the full work day. And we ended up with something like this. And this highlights our use cases. So to imbibe, to administer, and to notify. These were our main goals. And we have some Slack stuff that we were feeding data into. And this is what the holistic architecture sort of looks like. So at the baseline, we had the Beagle Bone Black, which had some other various hardware bits plugged into it, custom capes, and using Linux I2C to communicate with various things. Running Debian Linux with other system libraries. And then the Beagle Bone comes with node.js, although we actually upgraded Node on the system. And then on top of that, we have Express, which is a Node REST API framework. That's how we power the admin UI. Beagle Bone also comes with this bonescript thing I'll talk about a little bit more. And then we use Socket.io for events to communicate with the web admin UI. I'll show you a bit of that too. And then various REST APIs communicating back and forth so that we can monitor and administer different things. And I'll also talk about how we, on the Beagle Bone, we tried first to install Mongo on it, and then realized that it just wasn't quite powerful enough, and it seemed kind of crazy to do it that way. And Node.js, since Node is JavaScript and handles JSON really well, we decided just skip Mongo, and we'll actually use a tool called LowDB, which basically just makes JSON files into a database. So the basics. You really just need a mini fridge, CO2 tank, and a corny keg. That's the real basic hardware to put together, and of course the spigot comes out of that. These are the ones that we had to make sure we had source materials correct for, because all the other stuff varies, and you can just get it online sort of ad hoc. We happened to, I think we had the corny keg already, as well as the CO2 tank, because Michael is a home brewer. And the Danby mini fridge we actually got from Costco turned out to be a super awesome fridge because it had all the cooling unit materials on the back instead of the top, which was crucial because we drilled through the top in order to put the tubing and everything for the spigot. So then we knew we wanted to add to this, rather than just having a keg that spat out some liquid, we wanted to have some functionality around rate limiting. So we wanted to add, and this is really the purpose of the Beagle Bone Black, is to add an RFID reader and a flow meter into the process with a solenoid and ball valve, so that we could actually close the ball valve as soon as a rate limit event was detected. So we get into, I got a use case diagram a little bit later here. That's what the Beagle Bone Black looks like. It's basically just like a Raspberry Pi. Don't remember the exact reasons we went with Beagle Bone instead of Raspberry Pi, but just kind of went with it. I think you could build this with any kind of hardware like that. So the Beagle Bone has bonescript in it. Bonescript is kind of like, it's basically just a node.js library for interfacing with the pin connections. But like I said, it's got nodes, so occasionally for things like communicating with the LCD readout, we realized that the bonescript was just failing a lot of times, that we couldn't get the APIs that were documented to work. So we just went straight through Node.js to the file system and just used I2C to communicate with the device, and that worked beautifully. And then we had just regular Linux system commands that we could do. Actually, sorry, the Node we used fs create read stream for the RFID reader, which I have here. So this is what the RFID reader module looks like. Basically, you swipe one of these cards on top of that black bit, and then it goes beep, and then it sends a little signal off, and then we can compare that to our LowDB database of users with RFID numbers and see who's asking for beer. So that's what the code looks like for the read event. So basically, we just figure out what the USB device is that they're connecting to, create in Node.js and FS read stream on that device, and then when it gets a data event, we call back into the thing that's listening for that to compare that data to the user database, and we get a little string of it. Now, we did realize one fault with the RFID reader, and we haven't quite pinpointed if this is a fault with the USB itself on the Beagle Bone or with the RFID reader or what, but occasionally it would just sort of lose its connection. And so when we get this close event, we actually restart the process so that we can reestablish a connection with the USB. And we actually have a USB kicking module that we call if we find that it's dead. So there's a few things like that. We did not name this Kegerator after an animated cartoon character that's famous for drinking. I'm just going to put that out there. This is the user flow. So for the rate limiting, like a little light and hard to see. But basically, user starts out, scans the card on the RFID reader. RFID number comes back into the app. App checks that against the user database and sees, has the user reached its limit? So we set some arbitrary limits. We decided that you'd be able to pour 3 beers a day, and that you would get about a beer cup worth of beer per pour. So we had 2 different settings that we were looking for. So the first is to see, have you actually consumed enough milliliters for the day that you should be cut off? And if so, then we would display this message on an LCD readout to say, hey, sorry, you're cut off. If you are allowed, then it would open the ball valve and then display a little message on the LCD that says drink up. User then pulls the tap, and we start measuring flow through the flow meter. We just get those events streaming into the Beagle Bone. And then either the user releases and we stop flow, and then after 10 seconds we time out and close the ball valve so nobody else can come in and take your rate away. And then otherwise they hit their limit. So if you just keep it pulled and they hit the limit, then we automatically close the ball valve so you can sit there with the tap open and nothing will pour out. So the other enhancements, of course, for this were the LCD itself, which we built a custom cape for to attach to the Beagle Bone. And then we also wanted to add a temperature sensor. That's another IoT thing so that we can feed it into Slack if for some reason the mini fridge was getting too hot or something was going on there, we wanted to know and be able to correct that. So here's a little shot of the LCD attachment to the bone. Basically just, it's got some pin connectors, you connect it up according to the LCD spec, and it started reading out and working as soon as we started talking through the I2C stuff. So basically it looks like this. The I2C was a little bit funny because you got to clear it, and you got to go to home, then you've got to print on lines, and you could get it to behave a little funky, and if you actually overloaded the size of the screen, sometimes that would force the LCD to disconnect as well. And I think we also learned that you shouldn't cat the device because cat locks up the USB and dropped it off. So we had other ways of trying to figure out whether or not the device was present. So like I said, we had Slack. It was basically our cheap admin discovery because we wanted to load this up on the network and not necessarily have an idea of where it would appear in DNS. So we have it spitting out into a Slack channel, hey, I'm on 10.blah for the admin UI. And then also that would report the temperature settings. And then lastly, it would tell whether or not the volume is running low in the keg via the flow meter rate deprecation log. So now I'll go into a little bit about the admin panel. It's a simple UI, uses Backbone.js, Bootstrap, LowDB, like I said, JSON files, and then Socket.io. So it gives us stuff like this. Actually, I think I have a view of it running right here. So this is the admin panel itself. I can exit presentation mode. With the admin dashboard, potentially, if it's running. Maybe. Oh, there it goes. If somebody scans an RFID card and we don't recognize it, so this is because I'm not actually running a Beagle Bone Black attached to my computer right now, this is just doing a demo mode for an admin. It throws up this little alert so I can give it a username and assign the RFID to it. It's a little test. A lot of our code has this conditional of, are you actually running in desktop mode or on the Beagle Bone Black itself? Because I wanted to be able to run it on a machine that didn't actually have the Beagle Bone. So we have system configs. So each one of these entries here is basically just a LowDB JSON key value pair. And then the JavaScript itself, the Node app, just reads all that stuff and treats it. So we can actually update dynamically how many milliliters per pour without restarting the app, and it will feed that into the system. Then we've got users, what's in the keg, all that kind of stuff. Like I said, we condition this stuff. If we're in a desktop mode, then we just spit out some dummy things. So the temperature readout is just spitting out dummy data, unless you're actually running on the bone, and in that case, then it'll read from the sensor what's coming out of the temperature sensor itself. We had a few challenges. We do suck at industrial design, so the actual implementation of everything sitting on top of the damn mini fridge looks like it was just sort of hacked together. Stepping voltage turned out, seemed simple at first, but we actually fried a temperature sensor, so we're getting a new temperature sensor. The I2C stuff and the foreign hardware not playing nice, RFID disconnecting. There were a few challenges here and there with that. Turns out you have to clean the valve every now and then because it will actually get sticky. And we had people that were like, why is this not actually working? And then it turns out filling corny kegs is a pain. Nobody wants to fill those. So you have to just be a home brewer and fill them yourself. Unless you could find a very copacetic place that has beer. So this is kind of what it looks like. This is not an office. That's the kind of box that we have the Beagle Bone inside of, and all of the wiring goes in through this tube down to the system. A few lessons from use, or lack thereof. Change from user, that's sort of, you'd think that's a given, but when you're just hacking something together in a hackathon, you're like, yeah, bonescript, this thing, it just says just start, blah. And then you find out, a month later, oh yeah, we didn't change because we have a root Beagle Bone Black sitting there on the network. We should fix that. So change it immediately because you probably won't later. And then the second lesson is drink frequently. Like I said, if the keg just sits there, it will get incredibly sticky, and then you're going to have to take the thing apart and do hot water cleaning. It's kind of insane. So I have these slides up on GitHub pages, so there's a bit.ly link at the end here, so you can follow these if you want. This is the non-obvious list of materials, so the Beagle Bone Black, of course, fairly obvious, but LCD, all this stuff, we found parts on eBay or just sort of all over the place. I got the tap handle itself from Amazon. A lot of these things you can just get at Home Depot or general electronic stores or wherever. This is actually a toilet flange right here from Home Depot. So carved into the top and stuck the PVC, and then there it goes, and it actually sealed very well. So this is part of why we actually wanted the temperature sensor, because having put this thing together from scratch like this, we had no idea if there was going to be a huge leakage of temperature, and it turns out that it seemed to work okay. So we have a few next steps in the code base. The code is on GitHub, so I'll point to that. But we do need to do log rotation, so sort of spitting out the logs, and of course the Beagle Bone Black is sitting there going, storage. It's got like 4 gigs on it. We wanted to add Wi-Fi because it has an Ethernet port, but Wi-Fi is better. You don't have to have one extra cable sticking into a mini fridge. And then we do need to improve some of the USB RFID disconnect handling. Occasionally it still just drops off, and so you have to restart it. And there's certainly room for analytics in there. In the admin UI, we've got, I can actually get this running. There we go. In the admin UI, we've got basic usage charts. As somebody scans and consumes, you can get something like that. But this could be turned into, graphs and charts and whatnot of interesting measure. This is the temperature data. Actually, this is pretend temperature data. It's just being fed via socket I/O to the web browser. So as events happen, it'll show up in this graph. But yeah, we could add a lot more administrative enhancements to this. Let's see. We've got some LCD control in here. What's in the keg, so this shows up in the LCD as what's on tap. You can view service logs, restart it, change configs. But yeah, there's just some analytical reporting could be added to that. And we definitely need to replace the fried temperature sensor. So that's a big one. So this code is on GitHub. We took out the authentication from it because that was just using an internal little private thing, not like a public GitHub thing or whatever. So that could be added in as a plugin. That's pretty much it. Yeah. We've got code here, and the slides are on bit.ly Kegerator, so you can take my mouse away so you can take a picture of that. So, questions? Yes? What was the first beer you drank out of that? Yeah, it was your brew, wasn't it?
Yes.
Yeah. Then I think we had Seattle Ladies something in it next. Yeah. Yeah, the filling of the kegs. That's the challenge for sure. I'll be in a place to head up.
We get like a quarter pony keg and then everybody that way breweries.
Okay. Might be an option. Yeah. Yeah. Another one. I don't know if it was the flow sensor that did it, but we did realize because of the distance in the tubing here, of course, you're metering everything coming out from wherever the flow meter starts, which is like down here, and so you're getting this extra, however many milliliters up into the tube. That was also part of we're cutting off the ball valve up here, and then we have this sticky beer stuff sitting in the middle. That caused a few issues. But we tweaked the the CO2 a bit to try and get a better pour.
We had to buy a smaller flow meter. We started out with one that was only 2 bit. And I think we had trouble getting it to read. And I don't know if it was the combination with it, or if it was just that there was enough space in the flow meter that would go around it. So we had to find a really small one.
That's right, yeah.
I think it's 0.9 cents and milliliter on the read on there. So you get a really small diameter, but you get much better sensitivity. Where initially we started with this massive, and it just goes through and just really.
Yeah, when we get these volume counts, they come in fairly precise. So, yeah. Oh, it's a volume count. Yeah. That's it. Oh, wait, CJ.
Having been through this now, knowing what you know now, if you're starting from scratch, what would you do differently?
I would not drill through thin plastic. I think that's a good question. I think it all went pretty well, given it worked when we finished, right? I think part of it was just experimentation and sourcing of hardware. So now that we know that the Beagle Bone worked, right? We didn't have to buy so many of them. We knew we needed the smaller flow meter. Maybe not burning out the temp sensor, that kind of stuff. It was just a cheap temp sensor. I don't know.
Make it big enough for half cakes?
What's that?
Make it big enough for half
is it big enough? I know we could fit 2 cornies in there with the CO2, I think.
That fruit is a heck of a plant.
Yeah, I think it was like a 6 cubic foot or something. It's pretty big. Yeah, maybe 5.5. I don't know. But it's a Danby mini fridge. Yeah, so I don't know the exact model. Yeah, the trick was it didn't have a freezer component. It was literally just a fridge. And so that gives you a lot more space to work with.
On your Zen gear pointy thing, would you consider putting in commercial adapters so you can get gear from breweries?
Yeah, I think we talked about that a bit. We were just in the last month kind of going back and forth, going, wow, nobody wants to fill this. Nobody wants to fill this. What's the deal? Snow farm. Do you remember the model of the temp sensor? I wonder if Steve put that in.
It was the generic one we just got off of SmartFun.
This would probably work.
Do you have the spec on that? Is that
This is the one that Steve passed me. I think he was just searching eBay for things that were like the ones that we bought. Yeah, I mean it's.
I'd have to look it up. I had a handful at home, and honestly, we went with Beagle Bone Black because it was the camera that we knew. But it was also kind of a pain in the ass with stepping in the voltage, versus where you don't have to do that when it's very high.
Yeah.
Lower barrier to entry initially, but a lot more friction down the road with stepping voltage.
Yeah. I mean, these parts by themselves aren't very much. I mean, like $4 for an LCD, $5 for the push-pull motor driver. The ball valve itself is, $30, but yeah, piece it all together and it's a good project.
You said the ball valve wasn't actually that close to the spout.
I think it's like right up. Do you know where we put it in?
It's probably almost 3 feet, maybe 2.5.
Oh, is it actually down at the
it's-
base?
it's
Okay.
running- do you have a photo in there that shows both the CO2 and the tank itself?
I don't think I took a picture of the inside of the fridge.
You want it to be in the fridge.
Yeah, it's right down at the base.
Yeah.
But the problem is you get that when the oil comes off, there's like another 1.5 foot of tubing there going all the way up to the tap itself. So that's a little extra you're being charged for, if you will, and you're not necessarily combining them. Yeah, the next person thinks the lowest.
Right. It's not a lot of beer. And the unfortunate thing is, again, to drink frequently is the next person comes back a few days or a week later, that part's not as good. All right. Well, I think give you guys a little time at the end. So, thank you.
Yeah.